Okay, hi there, Zach. We are going to do lesson number 44 today, and if you're going to follow along, it starts on page 176 of your book. Lesson number 44 goes over addition of rational expressions when they have equal denominators and addition of rational expressions when they have unequal denominators. So this was sort of what we were setting up for last time when you were finding the least common multiple of algebraic expressions. And so we're going to start adding fractions that contain algebraic expressions. Some of them are going to have equal denominators, and some of them are going to have unequal denominators. So we're going to learn how to deal with both, okay? So the first thing is to remind you that how to add fractions, just so that we're all on the same page, right? So if we're going to add 1/11 plus 2/11, then you keep the denominators the same. It's going to be something over 11. And what you do is you just add the 1 plus 2 over 11, and then you end up with 3 over 11. And I know that seems simple, but just remember, when there's something really complicated here and really complicated here, you're going to keep the really complicated thing the same, and then you're going to add the numerators to each other, okay? And that's what we're going to start doing. So again, remember the rules for adding fractions when you have equal denominators. Fractions with equal denominators are added by adding the numerators algebraically and recording the sum over a single denominator, and just remember the denominator stays the same, right? So that's a good reminder, because then when you have something like this, then you kind of know what you need to do, because you have equal denominators here, so these are the same. So if you're going to add a bunch of things like this where the denominator is the same, you can do it, because we just did that with like the number 11 on the bottom. So the denominator is going to stay the same. It's going to be a plus 6. And what do we do with the numerators? Well, I think you know we're going to add them all together. So it's going to be 5 plus a plus b plus 2. And you can just simplify that to basically, well, let's just simplify it right now. It's going to be easy, because it's going to be 7, because I just added this over here, this 5 and this 2. 7 plus a plus b. And it's all going to be over a plus 6. Now, they did that in multiple steps in your book, but I think that you can figure that out, right? So, okay, so we see that when the denominators are the same, you can just add the numerators and record the sum over a single denominator. So we are going to jump right in to the examples now. So isn't that inspiring? We're just going to jump right in. Okay, example 44.1. We are going to add these two things together. And even though it says add, I want you to notice something, and this is something very important to notice. There is a minus sign here. So we are going to have to keep that in mind for sure, okay? So now the denominators are the same. So I kept the denominator the same down here. That's going to be the answer, that's going to be the denominator to the answer, is going to be these denominators. So what do we do with the tops? We just add them algebraically. So we're going to have 4, and it would basically be plus a negative 6ax. But instead of writing plus a negative, I'm just going to write 4 minus 6ax. We're lucky that there's only one term right here, because otherwise you would have to change the sign of every term. If there's like more terms here, like a minus 3 or something, you'd have to change it to a plus 3, right? So you have to change the sign on everything up here when you're adding it algebraically, and there's a negative sign there. So, but this is the answer here. So simple enough. And you know, as I know by this point, that we start out simple and we're going to get more complex. So boom, easy as that, but not so easy. It's going to get a little trickier. And here it's already trickier on example 44.2. Again, we do have the same denominator. So we have a squared plus 7y across all of these. So that's the good news. So I'm just going to make this, should I make it smaller? No, I can just write it underneath. So if I write it underneath, I'm going to do a squared plus 7y on the bottom. So I know that's going to be the denominator of my answer. Now on the top, I'm just going to add all the numerators. So it's going to be 5 minus 3 plus z. Now in your book, they separated it out into 3 different fractions, and then they added them together. But I don't know that you really need to do that step. Maybe if it gets more complicated, there's a reason. I don't know. But we can simplify this further because 5 minus 3 is just 2. So it's going to be 2 plus z. It's kind of like simplifying by adding like terms. So that's a like term, and you can simplify it to 2. The bottom remains the same, a squared plus 7y. So another easy one, or at least another straightforward one, we've got the answer to that one. What about 44.3? Here I put a caution sign here because I want you to be aware of this negative sign. So when we add the numerators, you got to be aware of this because this is really going to mess things up. And this is how you're going to get questions wrong, and I'm going to make you do them over again. So be very cautious of that. Now, we do see again that we have equal denominators, at least they are the same. So when I write my answer down here, I'm going to write 5a squared x, and then I'm just going to write the numerators. Now, maybe I will in this situation write it out again. No, I don't need to write it out again. That's so annoying. I don't know why they do that. I'm just going to add the numerators. Okay, so it's going to be 5x plus 7 minus 3x plus 2. Now, why did I do that? I did that because when you've got a minus sign here, it's basically like changing the signs of this and this. Now, this is a positive 3x because there's not another negative sign there. So I'm changing that positive to a negative. And then I'm changing this negative to a positive because minus this, it's like having parentheses around this whole thing, and you're going to have to change the sign of everything on the inside, right? So just something to be aware of because that is going to definitely make things tricky. Now, I'm going to simplify the top now because I can sort of add like terms. What are the like terms? Well, I've got this 5x and I've got a minus 3x, so I can write that as 2x. And then I've got a 7 plus 7 and a plus 2, so I can write 2x plus 9 over 5a squared x. And let's make sure that I got the same answer as the book, and I did. Okay, so wham bam, there you go. Thank you. Here we go. Let's go on to the next topic, which is addition of rational expressions. This time, we're going to make it harder because we have unequal denominators. So this is where it really gets annoying and complicated because we're going to have to find common denominators. All right, so here is a reminder of some important rules of algebra. And some people think these are the most important rules in the history of the universe, but definitely the most important rules of algebra. So we're going to review these important rules, and you have to pay lots of attention. Rule number 1, the same quantity can be added to both sides of an equation, right? So you have x equals y, you can do 1 plus x equals y plus 1. You can do that. Why can you do that? Because of the number 1 very important rule, the same quantity can be added to both sides of an equation. Number 2, very important rule. Every term on both sides of an equation can be multiplied or divided by the same quantity. What does that mean? That means if you have x equals y, you can say 3x equals 3y because I just divided or multiplied both sides of the equation by the same quantity. But I could also say, x over 3 equals y over 3. And now I just divided both sides by the same quantity. Very important rule, one that you've been doing all along, but it's just written out as an important rule, so you know the importance of it. Number 3, the denominator and numerator of a fraction can be multiplied by the same quantity. This is the rule that is going to come in handy for today's lesson. Write that down. Write that down. You need to know that. Okay. Now, this theorem is so important. It's not just a rule, it's called a theorem. This theorem is the fundamental theorem of fractions. Can it sound any more important than that, right? And what this book calls it, just to simplify it a little bit, instead of the fundamental theorem of fractions or the fundamental theorem of rational expressions, they call it the denominator-numerator same quantity rule, which I like that better personally. And it basically says the denominator and numerator of a fraction may be multiplied by the same non-zero quantity without changing the value of the fraction. In other words, let's say you have 1/4 plus 1/2. Okay, but this does not have a common denominator, so it's not easy to add. But if I take that rule and use that to change this, and I do times 2 to the numerator, times 2 to the denominator, I can change 1/2 into 2/4. And as that rule said, the denominator-numerator same quantity rule, this is the same quantity as this. So did I change anything? No, not really. But I changed everything. Because why? Because I can get rid of this, and in its place, I can do 1/4 plus 2/4. And now I can add two fractions with the same denominator, and this becomes an easy peasy problem, is 3/4. Because the denominator stays the same, the numerators are added. So I can multiply the top and bottom by the same thing, and it does not change the fraction. Now, what if I multiply the top and the bottom by x? Does that change it? No, it doesn't. As long as x is not 0, it's just like multiplying it by something equivalent to 1. You can multiply anything by 1. It doesn't change the value of it, right? So super important, something to keep in mind, and we're going to use it, I have a feeling, coming up in today's lesson. So let's do example 44.4. We're going to add these two fractions together, 3/4 plus 2/b. Now, these fractions are not equal, they're not equivalent, they're not even close. You've got a number and a letter, but we can use the denominator-numerator same quantity rule and a 3-step procedure to rewrite the fractions. And now they're going to be equivalent fractions, and they're going to have the same denominator. How do we do this? Easy peasy. Step 1. Step 1, we are going to make two blank fractions, something plus something. Okay? So we're just going to write it out like this. Now, if I had to pick a common denominator between this, a 4 and a b, we're going to write the least common multiple of the denominator. So we're going to write the LCM. And the LCM, as we learned before, has to have every single factor. Okay? So it's going to have a 4, and it's going to have a b. Let's just say it that way, and then we can make it easy. You could do 2 times 2 times b, and then, you get it the way that we have been doing in the past lessons. But basically, you know that it has to have a 4 and it has to have a b. So the least common multiple is what's going to go right down here as the new denominator. Okay, so I'm going to write 4b and 4b. Now, how do I change this fraction into 4b? Well, the way that we do that is we we write this like this. What did I multiply 4 by to get b? And we do this just like we do with any other fraction, right? How did we get from here to here? I multiplied by b. So that means I have to multiply the top by b, and I get 3b. So the top is going to be 3b. Now, what about, I'm going to erase this one. How do I turn this fraction into this fraction? I'm going to have to make that into something with 4b. Now, how did I get from here to here? I multiplied by 4. So that means I have to multiply the numerator by 4, and I get 8. Now, this is the new numerator that's going to go here. So I'm going to put 8 over 4b. And it turns out that if I erase, that this equation, 3/4 plus 2b, is exactly equivalent to this equation, 3b over 4b plus 8 over 4b. But now it's something that I can actually add together. And when I actually add this together, I know that the denominator is going to stay the same. And the top is going to have to be added. And since they're not like terms, I have to leave them like that. So this is the answer to that problem, okay? So that's actually really cool. I think that's kind of satisfying and fun to figure those out. So let's do this. Let's jump right in and do some of these other examples, okay? As you know, they get more complex, so don't skip ahead. I want you to learn how to do it. Here it's already more complex because they've asked us to add 3 things together. So step 1 is to find, well, I guess step 1 that they want us to do is to write the new fraction lines. So it's going to be a fraction, I want a fatter line. Okay, a fraction plus a fraction plus another fraction. Now, what is going to go on the denominator? The thing that's going to go on the denominator is the LCM of b, c, and 2. And since these are all basically broken down into their primes already, it's going to be 2b times c times 2, which is basically 2bc, right? So 2bc, I just like 2bc better. You could write bc2 if you wanted, it doesn't matter. But I like the number first and then sort of in alphabetical order. Now, let's move these out of the way for now and deal with that first fraction. What do I have to do to turn 4b into a fraction that has 2bc on the bottom? Well, to get from here to here, I had to multiply b times 2 and a c. So I had to do times 2c. So I have to multiply the numerator times 2c, and that's going to be 8c. So that's my very first fraction. Okay? Now, erase. Now, I'm done with this one. What about the second fraction? Let's take this one up here. How do I get this to equal something where the bottom is 2bc? What did I have to multiply? So it looks like I had to multiply c by 2 and a b. So that means I have to multiply the top by 2b, and that's just going to be a 2b on the top because there's just a 1 there. So that one was easy peasy, right? Easy peasy lemon squeezy, not too bad. I can get rid of that now. Now, let's take this last fraction, 1/2. What do I have to multiply to get this to equal 2bc? Well, I had to multiply it by bc. And so the top times bc is just going to be bc. Okay, so this is my new expression that I have to add together. Now, I know that my answer, let's move it and make it a little smaller. My answer is going to have a denominator of 2bc. The top is going to be 8c plus 2b plus bc. And there are no like terms there, so that's just the whole answer to the whole darn thing. Okay, so that is the right answer, and let's move on to the next one. The next one, challenge accepted. Do you accept the challenge of the next one? Let's do it. Let's do it. Okay, now, again, we're adding three things, three fractions. None of the denominators are the same. So step one, I'm going to write three fraction lines. 1, 2, 3. Now, what goes on the denominator? The denominator will be the LCM. When I have three letters, X and B and C, the LCM is just going to be XBC. So I'm going to write, I'll just write XBC. It's not in alphabetical order, but that's okay. Alrighty, now, erasey, erasey, let's get that out of the way. Let's get these things out of the way. All right, let's deal with the first one. What do I have to do to make this XBC? I have to multiply this by BC times BC. So the top has to be multiplied by BC, so the top is going to be 5BC. Okay. Easy peasy lemon squeezy. Now, excuse me, let's do the next one. The next one is X over B. What do I have to do to get that to be equal to XBC? I obviously have to multiply the bottom times an X and times a C. So the top is going to have to be X times C. Oh, look at what happens there. Now I have X squared and a C because I have an X times X and a C. So this is going to be X squared C. That was interesting. That's kind of fun, right? Kind of satisfying. Now let's do the last one. I'm going to bring up this last one. What do I have to do to turn this into something with a denominator that is XBC? I'm going to have to multiply this by XB. Now I'm going to have to multiply the top by XB. And I'm going to have AXB. AXB. Now, I am finally ready to add these stinking things together because I finally have common denominators. So, with a common denominator, I'm going to write on the bottom XBC because that doesn't change. Now, on the top, I'm just kind of scanning through. Is there any like terms that I can add? And it does not look like there are. So, it's just going to be 5BC plus X squared C plus AXB, and I thought I made my line long enough, and I did not. So that is the answer to 44.6. Done. Challenge accepted. Challenge completed. All right, example 44.7. This is the next one. Now, look at this. We're adding fraction, fraction, no fraction. So the step one is we've got to turn this into a fraction. This has a numerator and it has a bottom. This has a top, it has a bottom. This has a top, it has no bottom. That's why I put the minions there. They're laughing because I said bottom. Okay, so how do we turn that 6 into something with a bottom? Easy peasy. We put it on the numerator and we just give it a bottom, 1. Does that change anything? No. It's kind of like multiplying the top and the bottom by 1. Just the one on the top is invisible because it doesn't change the 6. So now we can do it like we were doing it before. Fraction line plus fraction line plus fraction line. What goes on the denominator? It's going to be, okay, I'm going to get rid of these guys because I need the space. And I'm going to move this over because I need the space. And I'm going to erasey because I need simplicity in my life. Okay, so we need the LCM on the bottom. Now the LCM, we might have to figure this one out because this is going to be CCC, this is going to be CC, and this is just 1. So basically, we need to use every factor, which is only a 1, which the 1 doesn't matter, so we can just leave that off. But we do have the C. Now, how many times? We use it the greatest number of times, so it's actually going to be CCC. So on the bottom is going to be C cubed. And that is going to be the common denominator, right? Okay, so now that makes sense to me. Now, how do I make each of those fractions into something that is going to have c cubed on the bottom? So this is something over c cubed. I didn't have to multiply that by anything, just by 1. So the top can stay the same. So that first one fraction is easy. It can just stay the same. What about this second fraction, 4 over c squared? So if I bring this up, 4 over c squared, I need to change this into something that has c cubed on the bottom. So I need to multiply it by one more c. So by another c, the top is going to be 4c. Okay, easy peasy, lemon squeezy, I got it. What about the last one? Ooh, the last one is minus 6. So there's a couple things that can mess you up here. And one is that minus sign. So I'm going to deal with that minus sign right now because me no likey, right? Let's erase it here. And let's erase that positive and just change this into a negative right now. Okay, now how do I get this into a fraction with c cubed on the bottom? I need to multiply this by c cubed. Now I need to multiply the top by c cubed. So the top is going to be 6c cubed. 6c cubed. And that makes sense to me as I look at this because 6c cubed over c cubed is basically just 6, right? But because I changed it to that, now I can add all of these expressions together. And when I add them all together, the denominator is just going to be c cubed. What about the numerator? We just add them. So m plus 4c, don't forget about this minus 6c cubed. And that, my friends, is going to be the final answer. The final frontier. Okay. Example 44.8. This one's on page 179. Pay close attention. We're almost done. We're going to find out how to add these fractions. Okay, so we've got p over 4 minus, pay attention to that, negative Ghost Rider, the pattern is full. We've got to pay attention to those negatives. A over 2 and c over b. Let us start this problem by doing 3 fraction lines. 1, 2, 3. Now, what goes on the bottom? The thing that goes on the bottom is the LCM. How do we calculate that? We've got a 4, which is 2 times 2. We've got a 2 here, which is just 1, 2, and we've got a b. So this is going to have to be 2 times 2 times b. So that's going to be 4b on the bottom. All the bottoms are going to be the same. All the bottoms are the same, and all the bottoms will be 4b. Okay, if you don't know how I did that, make sure you ask me how I did that, okay? Now, let's put this down here. Oh, you know what, though? Before I put it down here, let's deal with this negative sign because me no likey this negative sign. Let's change. Well, do I want to deal with that right now? Yeah, let's deal with it right now. Let's change this. We're going to change this to a negative. Okay. Alrighty, so let's get this out of the way. All right, what do I need to do to make p over 4 be something over 4b? Obviously, I need to multiply by b. Let's multiply the top by b. It's going to be pb. pb. All right. That is done. That is done. That is done. I dealt with that. I dealt with that. Next fraction. Okay. What do I need to do to make this something over 4b? I need to multiply it by 2, that's for sure, and another b. So the top is going to be times 2b. So this is going to be 2b or not 2b? 2ab. 2ab. Okay, got it, right? Got it? What about this last one? Let's deal with this one. CB. What do I need to do to make this something over 4B? I need to multiply by 4, that's for sure. Top by 4 is going to be 4C. Now I put a 4C here. Now I erase because I like cleanliness. Cleanliness. Okay, now we have common denominators. Finally, we can actually do this problem. We can add these together. The bottom is going to be the same bottom, 4B. The top is going to be PB minus 2AB plus 4C. Is that what they got in the book? Please tell me it is. Yes, it is. Woohoo! All right, last one. The last melon. I know you're probably so happy that this is the last one, and it's going to be great. Okay, let's do this one more time. This is how we learn math, by doing it, right? So this is the problem we need to do. Fraction plus fraction plus fraction. Luckily, there's no minus signs in this one, so we don't need to change that. But step one, let's find the LCM. The LCM, so this is going to be C times C. This is 2 times 2 times C times C times C. And this is 3 times C times C times C times C. So what is the LCM? We need a 2, and we need it twice. We need a C, and we need it 4 times. And we need a 3, and we need it just 1 time. I'll put it up there. Okay. So I think I got all the terms. So the thing that's going to go on the bottom is going to be 2 times 2, which is 4, times 3 is 12C4. So that's the new denominator, because that is the LCM between those things. So that was a little more complicated to find the LCM that time. So make sure that you're going through that process and knowing how to do it, okay? Now, let's move these out of the way. What do I need to do to make this something over 12C to the 4th? Well, I need to add another C squared, and I need to add a 12. So not add, multiply. So I need to multiply the top by 12C squared, which is going to be 12AC squared. So that's what I put here. Okay, erase. Now, this one. What do I need to do to make this something over 12C to the 4th? Well, I need to multiply the bottom by 3 and then 1 more C. And the top I need times 3 and 1 more C. So it's going to be 9C. Okay. Easy peasy lemon squeezy. Hopefully I'm not going too fast. Now this last one. What do I need to do to make this be equal to something over 12C to the 4th? I need to multiply it by 4. And then I don't need any more C's, so it's just times 4. So this is going to be 4M. All right, we're finally ready to solve this problem. It's going to be something over 12C to the 4th. And since none of these on the top are like terms, I'm just going to add them one after the other. 12AC squared plus 9C plus 4M. Okay. That is the final answer. And that is also the end of your lesson. And I am very pleased that you stuck with me this far. All right, good luck with your homework, Zach. Pay attention, do it right so you don't have to do it again. Okay, love you, bye.